All right, guys, we got a little experiment we're doing today. It's the old projectile motion simulation. All righty, so we're going to go right over to there it is, go into our FET. All righty, so the idea is we got to land our something, and we want to know exactly where that lands. So to that side, clicked on the thing. I'm going to have some choices here, what I want to do here. I can do the intro, I can do vectors, I can do drag, or I can actually do the lab. I think I have more choices if I do the lab, so I'm going to just jump on the lab side here. There we are. So I'm going to move this face over to here so it's out of the way. So we're not going to do anything terribly complicated, guys. Ooh, now it's in the way. All right, give me something to aim at. Okay. I'm going to go as big as I can. Nah, let's go to 10 meters. Let's see what happens at 10 meters. And for your lab, to make your math easier, we're going to shoot at 0 degrees at all times. So the ball's going to drop 10 meters. Ball, forget that. I'm shooting humans. Bam. Human cannonballer. All righty, I got to know where this thing's going to land. And guys, I'm all about max speed here. 30 meters per second. Okay. That means that I shoot a human out of this thing at 30 meters per second. Every second is going to go 30 meters this way. Does that make sense? Every single second. So now I got to figure out where to put my thingy. Let's say this is the cushion thing for my human, so the human doesn't die on hitting the road, it looks like here. Putting a nice cushy thing right over there. And I don't know if it's going to land on the 15 meters from there or not. So I can move this around. So I want to see where it goes at my max speed of 30 meters per second. Actually, I'm going to go to 20 meters per second because I have a feeling I'm going to go out of range. I have to change my thingies over there. So I'm going to just go back to 20. I'm going to back it off. Not as exciting. Sorry about that, but that's what I'm going to do. So every second, the human's going to be going 20 meters every single second. So now all I have to know is how long the human's in the air. And as soon as I find out how long the human's in the air, I'll know exactly how far to put this thing. Okay, because remember, something in motion stays in motion. There's not going to be any drag, not at this speed. I know it's 40 some miles per hour. Still, we're going to say the air resistance is negligible on this thing, so we're not going to worry about the air resistance portion of it. Okay, but we are dropping 10 meters. So how long does it take to drop 10 meters? Well, that's where we're going to have to do some math. Okay, so here we go. Let's do some annotating. And I don't have any pink on there, so we're going to stick with the pink today. So to find out how long in the air, well, then I'm going to need my vertical drop stuff. Okay. So my vertical drop stuff is my second equation, 1/2 AT squared plus the initial velocity times time. And on your equation sheet for the number 2 thing, it's going to give an initial spot right over there. So I know they're x's on your equation sheet, and technically they put a y on this, a subscript, and they put a y on that one, and you already have a y there. The reason is these are all vector amounts. They have to be in the same direction. Okay. But as this human comes out of this thing, comes flying out of this thing sideways, what's the initial velocity downward, which is this right here? How fast are they going downward? They're not. I like easy math. So how high is this right now? It's at 0 position. It's going to drop 10 meters. Okay. So I want to make that a -10. That's just making my math a little bit easier. Now remember, the reason I'm doing this, I'm solving for my time here. As soon as I know the time in the air, I'm going to find my distance because every second in the air is going 20 meters sideways. So to solve for my time, I'm going to go with 2 times the y, divide by the acceleration in the straight downward direction. That equals my t squared. Well, I need time, not t squared, so I do the square root of both sides, and that gets rid of that little dandy. And remember, this whole, it's over the whole thingy. So this is 2 times negative 10 meters. Remember, it's negative 10 because I called this my 0. I called that my 0, so down here is actually negative 10 meters. Just making my math easier for me. And if I want it to be really easy, I want to hit it spot on, guys. I'm not going to take the easy route out. This is a negative 9.81. That's an 8 meters per second squared. All righty. So, wow, got this big old thing. So I'm going to do the square root. I'm going to do my parentheses there. I'm not going to worry about the negatives because they cancel out. So I got my 20 on top, divided by my 9.8 on the bottom, in parentheses, and boom, 1.43 seconds, guys. This dude is going to be in the air, or dudette, could be a dudette, 1.43 seconds in the air. That's the hang time. So if I were just to drop this dude or dudette from 10 meters, it takes 1.43 seconds to hit the ground. You might have thought 1 second, right? Remember, you're accelerating. After 1 second, this dudette will be going 10 meters per second downward, but you're accelerating, okay? You're 1 second free fall if you're 5 meters high, okay? All righty, well, enough of that. So finally, how do you know where this person is going to land? Well, I'm going to switch equations. I'm going to go to my other favorite color, this green. So to find out where it lands, I'm going to use this v of x. Oh, that was a poor choice. That's just hard to see, isn't it? Well, stinks to be you guys. So solving for the x, because that's the how far the person goes. The reason for the sub x, you don't put numbers in there. Those are vector amounts. They have to be in the same direction horizontally. Notice there's no acceleration in there because we're not speeding up with no air resistance or slowing down. So the x is the v times the t, and horizontally it's a v of x, horizontally going 20 meters per second. Wow, that's very hard to see. And I'm old. But anyway, 1.43 seconds. All righty. So 20 times that, that's going to make that 28.6. That is hard to see, isn't it? So the change in position is 28.6 meters, right? So the decimal goes over 120. Yeah, I'm nailing it, guys. So that's where my target goes. And let me stop my annotation here. So now I can move to 28.6. There it is, guys. I hope you're as excited as I am. All righty. So if all goes well, boo, right on top of the thing. All right, let's hit it. Where's my fire button? There it is, guys. Firing away. Firing the hole. Boo! Nailed it. Wow, 3 stars. I wonder if I can get 5 next time. So the other part of this lab is not just finding what the landing really is, but the other portion is, what is that final velocity down there? Okay. What is the final velocity? I'm going to go with dark blue down there so we can see that stuff. So that was, I nailed it, guys. It landed right on there. But how fast was that person going the instant before hitting? That's the second part of your lab. Well, sideways, we're going how fast, guys? Well, it wasn't as easy as I thought to see that. Well, there it is anyway. The speed is 20 meters per second right there. So that's going 20 meters per second sideways. Hey, how fast was the person going downward there? Well, after 1.43 seconds, how fast would you be going? Well, to find that downward velocity, because the sideways didn't change, that's the first law. Newton's first law: in motion, stay in motion. There's nothing to speed up or slow down horizontally. However, downward, we're accelerating. So to find out what that velocity is, that's your first formula on your equation sheet there, that one, right? But we're going in the y direction, so I'm subscripting all these little y's here. Remember the original velocity coming out of that cannon there? That was a 0. So the v sub y is the negative 9.8 meters per second squared times the time of 1.43 seconds. So the velocity downward right before hitting at that 10 below, the velocity right before hitting the bottom is times 9.81, 14.0. So I drew it a little long there, didn't I? I drew it a little bit long. So it should be a little shorter than my 20. So that's a 14 meters per second that way. So upon hitting, it's going 20 meters per second sideways, 14 downward. Okay, let's do some vector addition here. Got to go pink so you guys can see the pink. So the net velocity is going that direction right there. So this is 14, which means this is 14. So to find the magnitude of that, that's the square of that plus 400, because that's the square of 20, 596.4, and I got to do the second function, square root of 596.4, 596. All right, so the magnitude is 24.4. So this pink line doing the Pythagorean theorem, that squared plus that squared, that is a velocity of 24. I'm just going to call it 24 meters per second. It is 24.4, but that's the speed. That's the speed upon hitting there. But if I want to get an angle, I could just do that one, and that's just going to be a trig thing using probably my opposite and my adjacent there, which would be a tangent function. Okay, so what color is tangent, everybody? I believe, if I remember right, tangent is that darker red right over there. I don't have room down there. If I write over here, maybe I can write over here. So if I wanted to do a tangent of that angle, that would equal the 14 over the 20. Okay, so there it is. So that's 7 over 10, which is 0.7. So basically I have to do the inverse tangent of 0.7, 35 degrees. Okay, so the angle is 35 degrees below horizon. There it is, guys. So step 1 done. I have one more to do, because for your lab you got to do not one but 2 of these, and don't pick 10 high at 20. You can change one of those. Don't do the same thing I did. Do something maybe original. Maybe do an 11, huh? That would be crazy. But my final answer is, so the person would land at 28.6 meters at a speed of 24.4 meters per second, or at a velocity of 24.4 hitting the target, which is at an angle of 35 degrees below the horizon. Done. Do one more of those. So what I would do is I'd take a screenshot of that, do another one, do a screenshot of that, put that on a piece of paper, put that in the student view, and there's your lab. You got 2 of these showing your work and everything else, or however you want to do that, guys. All righty. So that's the end of that.